In Lesson 1.5, we're going to learn about another simulation method, one that is a little bit more efficient than using dice and cards and spinners. And we are going to, in this section, learn how to use what's called a table of random digits to conduct a simulation. Now, the table of random digits looks like this excerpt that's printed in your notes, and it starts on line 101. A lot of them have hundreds and hundreds of lines, and basically what this is a table where every single digit number from 0 through 9 has an equally likely chance of occurring. So if you looked through the table and you counted up the number of ones, the number of twos, the number of sevens, etc., they all appear an equal number of times. The table is grouped in chunks of 5, which make it easier to count. And usually you'll be just given a couple of lines in the table, although you can find online a copy of the table of random digits if you want more than what's provided in your notes. Now, when we use the table of random digits for simulations, there are a couple of guidelines you have to follow. And like we did when we worked with spinners and coins and things, we have to kind of come up with a plan for how we're going to divide the outcomes to match the probabilities in the problem that we're trying to simulate. So with a table of random digits, all your groups of digits must be the same length. That means if you're working with one digit numbers, everything has to be a one digit number. If you're working with three digit numbers, everything will be a three digit number. You are going to start counting with either 0 if you're working with single digit numbers. You're going to start with double 0 if you're using two digit numbers, or you'll start with triple 0 if you're using three digit numbers. And technically you can use 4 or 5 digits, but we won't really go beyond 3 in this course because typically we're going to round to 3 places, so we'll stick with 3 digits. Now you're going to divide the digits according to the probability of the athlete's success or failure. And that will be based on their ability or what you think their ability is. And you're going to stop the simulation when the number of digits or groups of digits matches the number of attempts by the athletes. And you may not need to use all of the digits given. So sometimes you'll use just a very small number of them. Sometimes you'll use more than one row. It just depends on how many performances the athlete is attempting. So we're going to do an example in your notes with one digit and three digits. And then when you do your assignment, you'll try one with two digits to give you a little bit of practice with all those different types. In example number 1, it says use the table of random digits to simulate 15 foul shots by a player who normally makes 70% of her foul shots. The 70% is the athlete's ability, so that's what we're going to use when we divide up our digits. And the 15 is the number of performances that we're going to simulate. So first, let's change that 70% to a decimal. 70% is 0.70 or 0.7. And I want to use as few digits as possible. It just makes the simulation easier. So because I can express that percent as a single digit decimal, I'm going to use 0.7. Now, if you think about the possible single digit numbers and we list them all from 0 to 9, you can see that there are 10 possible digits there. And I need to divide those digits into groups of 70 and 30 because she has a 70% chance of being successful, which means a 30% chance of failure. Now, because we're starting with our counting at 0 instead of 1, I'm going to go from 0 to 6. And that represents the first 7 numbers. Okay. And that's kind of the tricky part about setting these up is you have to think about the ability and then you want to go one shy of that because you're always starting with 0. So you're not going up to 7, you're only going up to 6. And notice that that gives me 7 of the 10 numbers here. 70 out of 10 or 7 out of 10 is 70%. And that leaves me with 3 out of 10 here. So the numbers in that group of 7 represent success, which means she hits a foul shot. And the other group of 3 represents failure, where she's missing a foul shot. So when we set up our plan, we'll say let hit equal 0 to 6 and let a miss equal 7 to 9. So there's our plan. Now we're going to simulate 15 foul shots, and you've got a couple of rows of the random digit table there, and there's lots and lots of digits given there. We only need 15 of those digits. So 15 digits are just these first 3 groups of 5, and you can ignore all the other extra digits that are there. And then what you're going to do is you're going to go through those, each of those single digit numbers represents a shot. For example, the first shot is represented by the 5. And a 5 is between 0 and 6, so that means that she made the first shot. And the next one is a 2, which is also between 0 and 6, so that means she made the second shot. The third one is a 7, which means that one is a miss. And if we go through and we look through those first 15 digits, and I usually just put a little mark or maybe circle the ones that are a hit, notice then that we can count those up, and there are 8 of them altogether. So based on our simulation, the player made 8 out of 15 shots, and 8 out of 15 is 53.3%. So if we assume that her ability is 70% on this particular group of shots, she only made 53.3%. All right, let's do another example. In example number 2, we're going to simulate 20 at-bats by a baseball player whose lifetime batting average is 275. Now, batting average is already written as a decimal, but notice that that decimal is a 3-digit decimal place, right? 0.275. So we are going to have to look at 3-digit numbers this time. So if we were going to list out all the 3-digit numbers, essentially there would be 1,000 of them, right? Because we would start with 000, next we would have 001, 002, and so on, all the way up to 999. So how do we count off the first 275 random digits? Well, we wouldn't go all the way up to 275, because if we did that and we had the 0 in there, that would give us 276 of them. So where we need to stop our counting is we need to stop where 274 is the last one. Okay. And then anything from 275 and above means that the player would miss the ball or essentially get an out. All right, so we're going to say that everything from 000 to 274 is a hit, and an out would be 275 to 999. And notice everything there is written as a 3-digit number, including the 000, because we're going to be looking at groups of 3-digit numbers. Also notice I did not write these as decimals, right? We're looking at whole numbers from our table of random digits. Now this time we're simulating 20 at-bats, which means we need to look at 20 groups of 3-digit numbers. And depending on how comfortable you are with the table, sometimes what I'll do is go through and just block out 20 groups of numbers. And notice that that takes me beyond the first row and down into the second row, but I'm not going to use the entire second row. The other thing that you'll notice in this one as you're working your way through, when I'm counting out 3 numbers, this one stretches across the first and second group of 5, which is fine. That happens a lot, actually. When I get to the end of the first row, I've got this 1 digit left here at the end. And then we don't want to throw that out. We're going to still use that 3. So that will go together with the 6 and the 0 at the start of the next row. So we've got 1 and then 2, 3, and that's going to count as one of our groups of 3. So we don't throw out any digits from the row. Now what I'm going to do is look at each of those groups of 3 and count how many of them are between 0 and 274. So notice that one right there, 020, that's in that range. 118 is in that range. 167 is in that range. And then there are no other ones until I get down to the bottom row where there's that 241. So out of all those groups of 3, I only had 4 where the baseball player got a hit. So based on our simulation, the player had 4 hits in 20 at-bats. 4 out of 20 is 20%. So again, notice that that was a little bit below what we expected his performance to be based on his ability. But that happens sometimes due to random chance. Please do homework 1.5 in your assignment packet.